We've all heard the promises of revolutionary tech before, but this time it's not just hype. Imagine an engine that doesn't just match, but astonishingly delivers 5 times the power of a traditional diesel engine. That's right, you heard me correctly. 5 times the power, but it's not just any engine. It's a rotary engine, a concept that's been around for decades, but has always played second fiddle to its piston-driven cousins. Let's see. Liquid Piston, a pioneer in small and effective engine technology and hybrid power systems, plans to launch the XTS210, a 2-stroke, liquid-cooled, supercharged 210cc rotary engine with 25 horsepower. The XTS210 can run on gasoline, propane, hydrogen, and diesel in addition to heavy fuels, including kerosene, Jet A, JP8, and diesel. The XTS210 design preserves the same power output while reducing size and weight by about 80% when compared to existing piston diesel engines. How has this engine become more efficient than other engines? And is efficiency the only factor to be considered for an engine to be considered as efficient? Well, let's see. A new U.S. Army development contract worth $9 million to create a military prototype core engine was made based on the XTS210 design. The XTS210 engine, which represents the most recent iteration of Liquid Piston's X-engine platform architecture, overcomes the limits of the conventional Wankel rotary engine in terms of fuel economy, lubrication, and fuel type. The rotor and shaft are the only 2 major moving components of the X engine, making it a mechanically simple engine. The 25 horsepower XTS210 produces 6 combustion events per rotation of the rotor and may add up to 1 bar of boost by supercharging. It's a 2-stroke engine that delivers steady power from a lightweight package that is about the size of a basketball. If you're a person who analyzes the business of any brand as well as the products they release, you might know that every successful product will have a problem to solve. However, it doesn't matter how small the problem the product is solving. Similarly, the XTS210 specifically meets 4 important market needs. As compared to piston diesel engines of comparable output, the new rotary engine is able to produce 5 times the power to weight, power to volume, and up to 3 times the torque to weight. Additionally, it is incredibly portable and adjustable to run in hybrid electric and engine-only modes. 7,000 RPM maximum speed is compatible with lightweight and compact electrical equipment, providing enhanced mobility for hybrid and power generation applications. The new engine is capable of spark ignition or compression ignition and is liquid-cooled. Built from the ground up with military-grade durability in mind, it has multi-fuel capabilities. JP8 and Jet A fuels are the primary focus of testing for defense and aerospace applications. Demanding heavy fuel applications in both the military and the commercial sector will be satisfied by the XTS210 model. These applications include mobile electric power generation, primary or hybrid electric propulsive power for small unmanned aircraft systems, vertical takeoff and landing aircraft, and auxiliary power units for land, air, and marine vehicles, according to Dr. Alex Skolnick, co-founder and CEO of Liquid Piston. Today, there are virtually no diesel engines in the 25 horsepower power class that are appropriate for mobile military and aerospace applications, where weight and size constraints are particularly important. Moreover, he added that the XTS210's lowered weight, size, and heavy or multi-fuel capability provide substantial end-system capability and utility benefits, particularly for the military to lessen logistical and supply chain loads in a time when power on the go is becoming more and more crucial. We are eager to release this most recent iteration as our first X-engine model after over 20 years of groundbreaking thermodynamics research with several kinds of rotary diesel engines. Aren't you excited to explore the capabilities of this new rotary engine? Now let's consider the design aspects of the new rotary engine. Obviously, classic piston engines employ pistons, but this isn't the same. As the rotor revolves inside the chamber, its 3 curved sides act as pistons, compressing the fuel and air. Additionally, their compact design, quiet operation, and excellent power-to-weight ratio made them well known. Nevertheless, they became less well-liked because of their excessive gas use and emissions. On the other hand, by completely overhauling the Wankel engine, the XTS210 is designed to address a number of significant problems. According to co-founder and CEO of Liquid Piston Alex Skolnick, In contrast to the long, thin, moving combustion chamber of the XTS200, our fixed combustion chamber is well-rounded. All it takes to drive it to high compression is to reduce the chamber's size. Furthermore, he added that we can directly inject fuel where the Wankel could not, since it is immobile. Thus, high compression ratio and direct injection are the diesel's two main benefits. He continued, then there are our apex seals, which function similarly to piston rings. Once more, they are located inside the rotor of the Wankel engine. They are very difficult to lubricate, move quickly, and bounce about. They don't bounce around in our situation, and you can lube them right out of the housing. Moreover, Skolnick added that, with the help of this design, we have resolved the primary issues with oiling and combustion that the previous Rotaries experienced. These oiling difficulties led to concerns with emissions as well as durability. We overcome the limitations of the previous Rotary by making those components immobile. Additionally, we improved its cycle to offer it far more efficiency. We might have learned about the normal thermodynamic cycles in our academics. However, this rotary engine incorporates a special thermodynamic cycle named the high-efficiency hybrid cycle. High compression ratio air compression, fuel injection, and compression ignition are required for optimal efficiency. The spark ignition cycle used in the X-Mini has a lower compression ratio than the typical gasoline engine. Combustion is forced to occur at essentially constant volume conditions during a lingering around the top dead center. As in the Atkinson cycle, combustion products are overexpanded by employing a greater expansion volume than compression volume. Cycle-skipping power modulation provides partial heat recovery and internal engine cooling at lower power settings, all while enabling excellent efficiency. The engine can be internally cooled by injecting water. As the water transforms into steam and raises the chamber pressure, some of this cooling energy is recovered. Following the creation of the high-efficiency hybrid cycle thermodynamic cycle in 2003, Doctors Nikolai and Alexander Skolnick founded Liquid Piston Inc. with an engine design that incorporated this type of cycling. 2 decades later, the technological startup that won the MIT Award is currently developing and testing its engines at a 12,000 square foot facility in Bloomfield, Connecticut. The majority of the work is produced in-house by the company, using CNC machining and assembly skills after all software engineering and modeling engine system settings are finished. Liquid Piston has been developing these X engines for about 20 years. Many of the prototypes have already been tested in go-karts and tiny planes. As seen above, additional prototypes have incorporated force induction engines with up to 70 horsepower and normally aspirated variants with up to 40 horsepower. These have been operated on diesel, gasoline, hydrogen, and propane. Currently, the XTS210 is being developed on JP8 Jet A fuel because it's widely used in aircraft and defense. According to a news statement from Skolnick, there are essentially no diesel engines in the 25 horsepower power class that are acceptable for aerospace and mobile military applications, where size and weight constraints are extremely vital. The XTS210's lowered weight, size, and heavier multi-fuel capacity provide substantial end-system capability and usability benefits, particularly for the military, to lessen logistical and supply chain demands in a time when power on the go is becoming more and more crucial. By 2024, Liquid Piston hopes to have an XTS210 prototype in the hands of the U.S. Army. The business has previously developed a number of rotary X engine prototypes that show a great deal of engine architectural diversity. These include naturally aspirated 4-stroke versions with 5 to 40 horsepower. Apart from the recent $9 million contract to support the XTS210 development, Liquid Piston was also awarded a $1.7 million contract by the Army to power a hybrid electric VTOL UAV demonstration. With this, the company's contracts with the Department of Defense now amount to more than $30 million. And that, folks, brings us to the end of an electrifying journey into the world of revolutionary rotary engines. But before we power down, remember, this isn't just a glimpse into futuristic engineering. It's a doorway into a realm where the impossible becomes possible. And for our subscribers, here's a sneak peek. In our next episode, we're diving deep into how this new rotary engine could potentially integrate with electric vehicle technology. Could this be the hybrid model that changes the game? You won't want to miss it. Your likes, comments, and shares fuel our passion and drive our content. So, if you haven't already, smash that like button and subscribe to our channel. Be a part of a community that's at the forefront of technological innovation. So, as we rev up our engines to bring you more groundbreaking content, remember, in the world of innovation, the next big thing is just around the corner. Stay curious, stay informed, and stay tuned.